The washing machine is dead, and diagnosis points to a fault in the power supply circuit of the board. Before we start, a necessary note. Today we're working with 220V mains voltage. If you don't have basic knowledge of electronics and don't know how to protect yourself from electric shock, do not attempt this repair on your own. Contact a specialist. For those of you who have the skills and know how to safely handle a soldering iron and a multimeter, stay here. We'll analyze the fault in the AC-DC converter. We'll find the burnt protection resistor, the IC, and see how to bring the board back to life at minimum cost, avoiding replacing the entire module. Let's go through the process step by step. So, this is our board. We see it has some black spots on it, which some might think are damage, something burnt, but in reality these black marks come from the glue and the heat that these devices develop. On this board we'll locate the power supply since our device is dead. Here we see a capacitor rated at 400V next to one at 25V, and we also see an inductor here in the middle. So I immediately understand that the 400V capacitor is for smoothing the DC voltage from rectifying the 220V. The small inductor does the job of a transformer, and the 25V capacitor is for rectification and smoothing on the output of the power supply. And if we look underneath, we expect to find the switch, the MOSFET, and the oscillator, which are integrated into this IC here, both in one. And we also see two small diodes, one for rectifying the 220V and the other for our output. Now let's locate the machine's fuse. This particular machine doesn't have a standard fuse. It has a fuse-resistor. It's a resistor that limits the current, and if a short circuit occurs, it burns out. It is this one here, specifically this one. If we look at the solder side from below, we'll notice that the 220V comes directly into this resistor. They pass through it and go to the diode to rectify and continue the circuit to the capacitor and the oscillator. So the first measurement we'll take is on this resistor with our multimeter to see if it's burnt. Very important, as we've said before. Not just to say, wow, burnt resistor, we found the fault, but to see how we proceed. Further down the circuit, we see here, measuring it, that it's open, burnt our resistor. And we understand that downstream we expect a short circuit which could come from either the rectifier diode for the 220V or the IC, oscillator plus MOSFET, or from the 400V smoothing capacitor. For the second measurement, I'll measure directly on the IC on the pins where the MOSFET is. These are the pins, and I measure with my multimeter. I see on the meter that I have 9 ohms. 9 ohms is a short circuit, so it's most likely that the IC is burnt. But I'll also check the surrounding components, mainly the two diodes I see here, to see if they are also shorted. We see here that they don't show a short, so the next step is to remove the IC and the resistor, of course, which is burnt, and measure the circuit again to see if the short is gone. Let's proceed to do that. We've removed the IC. Now let's measure on the pins where we had the short before with our ohm meter to see if it's gone. And we see here we are clear. The short is gone. So it was definitely the IC that was burnt. The IC will be replaced, and to be sure we don't burn it again, instead of the resistor I'll use a 220V bulb, which will be placed in the resistor's position so that when we plug it in, if there's another problem downstream, another short that we haven't detected, the bulb will stay on, it will light up, and it won't burn our new IC again. This is a tip I use very often. If you've seen my videos, when I find a blown fuse, I never put a new fuse in and plug it in. I usually put a bulb in place of the fuse instead of the fuse, and only then I plug it in so I don't burn the new components I've installed. I locate where the power goes in, and I'll solder a 220V cable, as I said, to plug it in and see if there's any other problem. Okay. We plug it in and we see the bulb doesn't light up. It didn't turn on, so we have no other short. I don't see it doing anything. It doesn't have any LEDs on top, though. Underneath, oops, you see LEDs lit up. The board started. It's working normally. Now you see here it also responds to functions if we press buttons. So we don't have any other issues. Since it works with the bulb in place, we have no other problem. Basically, the power supply worked. We'll put the resistor back on its original, of course, the fuse resistor. Let's do our final test to measure if the output voltages are correct and we're good. Alright, we plug it in. And we see that the LEDs lit up. Now we have the circuit normally with the fuse resistor in place. We see the LEDs are alive here. So we're good, the power supply works. Let's also do a standard voltage measurement. To check the voltages, it should have 2, 15 and 5. Here we go. We have both. So we've finished our repair. That was it. We'll install it back in the device to test it for a while and we're good. The repair is complete and the board is now properly powered. As you saw, understanding the circuit allows us to fix faults that many would consider irreparable. I want to emphasize again, safety is paramount. Never test the board on mains power if you're not sure about your insulation and soldering. Thank you for watching. If you have any questions about the components or the process, write to me in the comments. If the video helped you, hit like, share it, because as we say, knowledge should be shared. Good luck with your repairs. Goodbye, everyone.